Hey kiddos, here's the feedback video for Spiral 11. We're going to start off with properties of exponents and polynomial basics. And first up we've got to multiply some things together that have common bases in exponents. The first thing I want to talk about is that the numbers that are multiplied here are kind of their own thing. And that's always the first category of things we're going to multiply. So we've got 4 times 3, and that's going to be 12. Next up we've got x to the 4th and an x. I'm going to put a 1 up there so I know that power is 1. And I know that when I'm multiplying things that have the same base, I'm going to add those exponents. So 4 plus 1 would give us x to the 5th. And then finally the y, which probably is the easiest part of the whole problem, is going to be y squared times y squared would give us y to the 4th. The biggest mistake I'm seeing is leaving those numbers separate. And the second biggest mistake I'm seeing is not noticing that that power should be 1 for that x. Please be careful that this is not distribution and that this is trying to, it's kind of like combining like terms for multiplication. For number 7, we're looking at doing the same thing but with dividing. One of the things that might be helpful, is to take a look at this in terms of we've got 1 over 3 times 1 over x cubed times y to the 3rd over y squared. And I think this might be useful because it reminds us that if we cancel things out, we're not actually getting rid of a whole numerator of a fraction. So the one thing that really can do anything here is that y to the 3 over y to the 2 is going to become y to the 1 because 3 minus 2 is 1. And I saw a lot of, okay, that means the whole top part of this is going away. But in reality, these pieces, the 1/3 and the x to the 3, are going to stay in the bottom. So you can leave this as y to the 1, or just y, over 3x to the 3rd. You could also write this as 1/3 times 1 over x to the 3rd times y, and that would be okay. Either one of these two answers or anything that's the same thing would be totally fine for this. For problem number 3, the biggest issue that I'm seeing here is not seeing a plus here, and instead trying to do distribution, which is not what this is asking you to do. This is really combining like terms problem, and we're going to start off with x to the 4th plus negative x to the 4th. When I'm adding these two things together, we get 0 because they cancel each other out. But I want to make sure that we understand that when we're adding things, that the exponents don't change. This would be like saying, if I've got 1 apple and I'm taking away an apple, then I have none of those things left. So this is going to come into play again when I have negative 6x squared, then a plus negative 9x squared. When I add these two things together, we get negative 15, but the x squared parts don't change. That's going to stay x squared and give us an answer of negative 15x squared for that piece. The third part, we've got 8x and then plus minus 11x. 8x plus negative 11x is going to be negative 3x. And again, since we're adding those types of things together, we just add the coefficients. We don't actually add anything to the exponents. So I could write this as 0 minus 15x squared minus 3x, or just negative 15x squared minus 3x, and I'd be totally done at that point. For number 9, this one went pretty well in the spiral. Most of us saw that this was distribution. I've got to distribute the negative 6x to all 3 pieces, and then do the same thing with that negative 5. So when I go about and do that, negative 6x times negative 3x squared is going to be 18x to the 3rd power, because that's x to the 1. And then we've got negative 6 times 5, which is minus 30. X times x is x squared. And then negative 6x times negative 2 is going to be plus 12x. Going to keep it going for minus 5. Minus 5 times minus 3x squared is plus 15x squared. Minus 5 times plus 5x is minus 25x. And minus 5 times minus 2 is plus 10. I like lining these things up because it makes adding them together afterwards easier, because then I'm just adding down. So we get 18x to the third. Minus 30 plus 15 is minus 15x squared. Plus 12 and minus 25 is minus 13x. We get a plus 10 at the end. There were a lot of arithmetic mistakes here, adding like negative 30 and 15 and getting 45 and things like that. But for the most part, this one was pretty good. Moving on to factoring and graphing polynomials. This was the newest topic. We also had a break in between learning about this and spiraling for many of us. So this was one that we had a lot of trouble with. When we're asked to find all the real number roots, the first thing we want to do is to factor this. And then roots are the same as zeros. So I'm going to call this root or zero finding. And when we're factoring this, I notice that all of these pieces have an x. That means I'm going to take an x out of all of the parts. So we get x, then x squared minus 7x, and then plus 12. Once we do that, we're going to factor the inside. A times c is going to be 12, and we're going to add up to negative 7. In this case, that's going to be negative 4 and negative 3. Because we have a simpler problem, what we can do is just treat that as the things in parentheses. So we got x minus 4 and x minus 3. That gives us 3 answers. So this is fully factored. The first root or 0 would be at x equals 0. The second would be at x minus 4 equals 0, which means that x is equal to 4. And the last one would be at x minus 3 equals 0, which means that x is equal to 3. All right. Just to kind of put these on the graph, we've got at 0, we've got at 3, and we've got at 4. Okay, the y-intercept is going to be at 0, because that's where we have that point. The end behavior, this is based on this being a positive graph, and by that I mean that this very first piece is a positive number. So that means we're going to go up at the end. And if I trace that through, we end up going through the 4, we end up going through the 3, and through the 0. We end up with an N-shaped graph that looks something like this. I like doing this side before attacking the end behavior because that lets me kind of see a visual before I try to do this. So one thing I'd like us to think about is as x approaches negative infinity, we're talking about going to the left. And as we're going to the left, our graph is going down. So if this is going to be down, that's going to be negative infinity for the y. I can do the same thing on the right side. As x approaches infinity, means as our graph goes to the right. And as we go to the right, we're going up. I just spelled up with 2 P's. That's fun. And then that's going to be positive infinity for this one. And then finally, we've got a graph given we got to write a polynomial equation in factored form. The one thing that I notice is that there's a bounce at x equals 5. And what I'd like us to remember is that anytime we see a bounce, it's going to be that thing squared. So let's start building this thing. So we know it's going to be some number out front. We'll deal with that in a minute. And then we got x. The negative 4 is going to give us x plus 4. It's always the opposite. Positive 2 would give us x minus 2. And then the x5 would give us minus 5. And we said this would have to be squared. To figure out what number is going to be in front of this, I'm going to use the y-intercept. That's where that negative 200 comes in. And what we do is we plug in negative 200 for y. And we're going to plug in 0 for x. So that gives us negative 200 is equal to a, whatever number that is, times 0 plus 4 is 4, times 0 minus 2 is times negative 2, and 0 minus 5 is going to be minus 5, but we still have that squared there, so that's going to be squared. I'm going to clean this up a little bit, so negative 200, and we've got a times 4 times negative 2 is 8, negative 8, and negative 5 times negative 5 is 25. And negative 8 times 25 is going to be negative 200. And the nice thing about that is that it means that a has to be 1. So our final answer, even if you didn't realize you had to do that a part, you might have gotten the right thing by putting the parentheses in and squaring that x minus 5.